actually, let me start with questions. Do you guys have any questions that you can articulate? Now, you all got IntelliJ more or less working, got Gradle more or less working, submitted assignment 0.
Well, I'm having trouble running with the feature. When I run add.feature, I'm getting the message unknown error. And then
Okay, if you don't mind, we can say after class and fix it.
okay.
Right, and we can, but also keep in mind that IntelliJ is nice, but it's not a necessity, right? You can just do it with Gradle and Gradle W test, and that's it, right? And just use any other text editor to edit, right? Text editor, not word processor, right? But, and you sort of figure out Git and assignment 0 and how to submit and GitLab and that stuff, right? By now, you should, if you submitted assignment 0, right, you should be able to see your merge requests. If you go to any, I have no clue who this is. There should be merge requests. So you should be able to go see. If the merge request was okay, I usually merge them. That means it's done. And I put the grade, so you can also go to D2L and look at the grade. I'll merge them. It will be okay. If they are not okay, or if I want you to do more work, I normally close them rather than merging them. And I tend to not put a grade in that case because you can submit again, right? So it's not a 0, it's a not yet, right? For the most part, I would assume that most of you would get 100 on all your assignments, right? Because you can resubmit until you work it. In both cases, I may make comments on your merge request. Those tend to be, well, if the merge request was closed, then I will tell you why, right? What is wrong, what is happening, and I will go inside and maybe give you hints or things like that, right? Tell you, and we can have a dialogue. You can submit again, and we can, right? You can change the file, submit again. We can have a dialogue. You can comment on those things. If it is merged, I may still leave comments. Those tend to be more kind of improvements, style points, those kinds of things. Because, well, it was merged. It worked, right? And working is the biggest quality in software, right? It works. But then actually you want it not just to work, but to be understandable for the poor next guy who comes change it, right? And you know, chances are, who is that poor next guy, right? It's you on Monday morning, on Friday evening when you want to leave, right? So I tend to make those kinds of comments. If you want, you can take them and play with those things or do the changes, and you can submit again if you want. That's perfectly okay. Cool.
So what would the grade be?
In D2L.
What is the Wi-Fi password?
I have no clue whatsoever, but they do.
Okay, thank you.
My computer knows, probably, because it's hooked up, right? So let's talk a little bit about this idea of variables, right? And I'm going to be using Java REPL probably for this lecture, maybe. Once we get to more advanced things, it's a pain to use Java REPL, so I stop. A variable is a name location in memory. Variables in Java have a name, a type, and a value. You can think of a variable as a box, so it can contain values, and you give it a name so you can refer to it, right? So you can say program put this value in this box or get the value from this box and do stuff with it, right? We declare a variable by putting its type and its name. We assign values to variables like this, a equals 10. Reminder, this is not math, this is not algebra, this is go make a 10. Go put a 10 in the a box, right? Because we can later do this, which would change the value of a. So in math, your math teacher would go nuts. This is not math. It looks like it, but it's not. Does that make sense? So we can do things like this. We can declare and initialize in the same line, so int c equals 10. And then we can do things like this, where we declare a bunch of variables. We are using commas. So we declare a bunch of variables and assign values to them. In Java, statements end with a semicolon, usually. Just in case you care, variables in Java are composed of letters, numbers, $sign, and underscore. They cannot start with a digit because then Java would get confused between an integer constant or a variable name. The important thing is that you should make the variables readable. They should have a meaning that's easy to see, right? So at some point in time, there is a trade-off between readability and carpal tunnel syndrome, because ideally you would have variables that are 17 words long, but that becomes cumbersome after a while. So you have to figure out variable naming, and that's actually a much harder thing than it seems. We gloss over it because this is a computer science, and variable naming is philosophy, not computer science, right? But you should try to do things like that. In Java, there is a very strong convention to start variables with lowercase letter, use capitalization to separate words. So you would do gear ratio as the name of your variable, or number of sides. It is usually a bad idea to use abbreviations or something like that, except for very specific exceptions. But does that idea make sense? So we can do stuff like, let's go to Java repo. Int number, can you see? Close enough? Then we can do int perimeter equals number of times size. Ah, beautiful. Now you can see better. Does this idea make sense? In IntelliJ, you can't do this. You have to put it inside a full program. We'll talk what full programs are. Just in case you care, I tend to post this on YouTube, so you don't have to take pictures of the screen or anything like that. We have the basic operators in Java. We have plus and minus. Times is an asterisk, a weird star, because x is the letter x, not the symbol for multiplication. And slash is the integer division operator. When you are doing, slash is the division operator. When you are doing ints, right? When you're playing with two integers or integer kind things, then the division will be done as integer division. How much is 6 divided by 4? 1, right? Have to go back to elementary school. Percent is the remainder or modulo operator. So how much is 6 modulo 4? 2. Right? We can mix and match with the usual orders. The acronym that my kids saw in school in the US was PEMDAS, right? Parentheses, exponents, there is no sign for exponent. Multiplication, division, addition, and subtraction. Really, multiplication and division go in the same order, and then addition and subtraction go in the same order. And parentheses change order. So if you get confused about which goes first, what do? Add parentheses or add intermediate variables, right? Make sense? Slightly confusing. We support shorthand operators. Instead of writing a equals a plus 5, we can write a plus equals 5. And so we save 2 characters. That means you get carpal tunnel syndrome at 50 rather than at 45. It works for all of them, so you can do b times equals 3. And then there are 2 special ones, plus plus and minus minus. Plus plus means add 1 to it. So b plus plus means add 1 to b. And then minus minus means subtract 1. So b minus minus means b equals b minus 1. And those you can also write them the other. You can also write plus plus b and minus minus b. You definitely need to be able to read these operators because most people use them. And then if you don't want to use them, that's perfectly okay. I am assuming that you guys would have a learning curve or a familiarity curve. So in the beginning, you probably want to spell it out, right? And then as you become more familiar with it, as the weeks go by and you use them 700 times, then you'll start using the shorthand operators. Okay, what would the value of x be at the end of this code fragment?
$25.
25, right? Int a equals 10, int b equals 3 times a, so b is going to be 30. And then x equals b minus 5, so it's 21, right? Oh, well. Oh, well. Besides integers, right? And most of the time we'll be dealing with integers. They're simple to understand. So we use them a lot as examples, right? In real life, you use them a lot too, but you also use other things. One kind of numbers that makes a lot of sense for scientific computing is floating point numbers. If you remember, at some point in time, probably in high school, they tortured you with scientific notation, right? 3.5 times 10 to the 7, that kind of stuff. You remember? In computers, we use that same kind of stuff. In computers, the size in memory is going to be important, and it is measured in bits. Integers in Java, I think, are 32 bits, which gives you from like minus 2.5 billion to 2.5 billion as a range. And then if you go above that, you can't represent it anymore, right? It's, you can't fit that many digits. It's like a form that has the squares marked for the number of digits, right? with floating point, we do the same, but we reserve some bits for the mantissa and some bits for the exponent. And the exponents are binary, so this stuff doesn't map to decimal, right? I mean, it's the same concept, it's just in binary. What happens with these kinds of things? They allow us to represent a much bigger range of numbers, but we lose precision. This is not useful for accounting, right? In accounting, if you lose a penny, then the accountant is gonna be on you to try to figure out the penny, right? Because it could signal something important. But it is useful for the other kind of real life counting, right? What's the distance from the Earth to the Moon? Siri, what's it now? I actually have, okay, Google. Yeah. Let's say that you could say something like, it's 10,000 kilometers, right? Or what's the circumference of the Earth? It's 40,000 kilometers, right? Because but it's not true, right? It's about 40,000 kilometers, right? Depends on where you measure. Do you measure over the Everest or not, right? But it's good enough, right? If you're talking about 40,000 kilometers, then it doesn't matter if you're doing, if it's 40,000 and 100 meters, right? That's not gonna matter. It would matter if it's 41 or 42 maybe, right? But not, the stuff at the very end doesn't terribly matter. That's what floating point represents, right? In floating point numbers, maybe 40,000 and 40,001 are represented as the exact same number. So it really can't distinguish between 40,000 and 40,001. But it doesn't terribly matter. You would be able to distinguish between 1 and 2 when the difference is big in relative terms. But you would not, right? And maybe in the billions, right? You'll not be able to distinguish between 25 billion and 25 billion and 10,000, right? Or something like that, right? That stuff, you can go figure out by either Googling that stuff and figuring out how many bits you have for each thing and figure out the actual precision, or typing this stuff in your computer and seeing what happens, right? Does that idea make sense? There are several kinds of integers depending on their size. So we have int, which is the regular one, which I think is 32 bits, and then long, which is 64 bits. With floating points, and we normally use ints because that's good enough. With floating points, we have two kinds of floating points. We have float and double. I'm chicken with floating point numbers, right? So which one do you always use? Double, because it has more precision. I don't want to figure out how much precision I gain or lose. I just want the best I can, right? And it's usually not a big deal because you have it in hardware. It's not that big of a deal in terms of performance. So I will normally use doubles, and I almost never use floats, just because lazy thinking. With floating point operators, with floating points, you have all these standard operators. You don't have percent. Actually, you may have it. Let's see. Double A equals 10. B equals 11.1. Then can I do percent? I don't know if it will work. Oh! Yes, it calculates it, except that it does whatever the heck it feels like it. You do have a percent operator for doubles. It just doesn't do what you think it would do. Right.
What does RES like?
It's just Java REPL gives it a name so that you can refer to it. So res, and then it starts putting numbers to it, 2, 3. So whatever we do next will be res for. Just so you can actually do this, because Java REPL is mixing Java and trying to make it almost like a calculator. This is not what happens in IntelliJ, right? It's just Java REPL gives you a way to reference those things. One other thing that doesn't make sense, and we'll see in a second, the equal operator allows you to compare two values. It doesn't make a lot of sense with floating point numbers. Why? Because we want to know, right? You could do things that give you values that are very close, and so the floating point doesn't really have a good concept of equality. You're going to be doing stuff and losing precision here and there. So it may not matter whether you do 10 million or 10 million and 1. And so normally with floating point operators, we don't use equality. Okay. Any questions about ints and floating points and variables? No? Cool. There is another one that we want to do, which is Boolean. George Boole was a mathematician that kind of formalized this kind of stuff, and so we tend to call these things Booleans. Booleans are things that have true or false, right? And if you probably again sometime in high school, right, you saw some logic, right, and they talk about true and false and variables, right? A Boolean is something that can only be true or false. It only has two possible values, right? So what's the answer to is today Tuesday? Right? You may not know, but it's either yes or no, right? It's either true or false. And so we can declare variables of type Boolean and then assign them the constants true or false. So we can do Boolean is today Tuesday, which is equal to what? True, right? Today's Tuesday. Now, what kinds of things can we, well, what kinds of things can generate Booleans, right? We have operators on ints that generate Booleans, right? So I can do, I don't have, well, let's see. Or int AA equals 1. If I ask A equals 1, what's the answer? It's either true or false. And this is false. If I do AA equals 1, right, it is true. Why do we have to use two equals? Because one equal means assignment, means making one, right? And so we use two equals for comparison. In programming, we actually use the assignment a lot more than the comparison, so it makes sense to reserve the shorter one for assignment. Does this make sense? What other things can we do to generate Booleans? Less than or equal, less than, greater than or equal. And we get Booleans, either true or false. Make sense? Now, how can we combine Boolean values? Do we have operators that work on Booleans? We do, right? Which ones are those? In English, how do you combine Boolean values? Or an and, right? And not. So we have those three things in programming. So we have one Boolean. Okay, let me do Boolean, I'm lazy, B1 equals true, B2, B1 and we use double ampersands because of historical reasons. B1 and B2. What's the answer to that? False. Why? Because both of them have to be true, right? And one of them is false. Does that make sense? If we use OR, and for OR we use the weird vertical bar, and again we use 2, is the vertical bar, it's above the slash on most keyboards. It used to have a hole in the middle, but I guess it doesn't anymore in most fonts. What would that tell us? True, right? And then we can use bang for not B1 say false, and not B2 would say true, right? And again, we can combine them, and again, we can use parentheses.
For not, is that an exclamation point?
Exclamation point is not, so it's bang. It's flip it, right? If it was true, it becomes false. If it was false, it becomes true. We can combine these. One important thing, OR is the mathematical OR, the logical OR, not the English OR. Well, sort of the English OR. What's the difference? In English, there is a presumption that OR is exclusive, right? In logic, there is no such thing, right? If this is true and this is true, this or this will also be true, right? Which in English, it's okay, it's just weird, right? But if you ask any kid, what do you want, ice cream or cake? What's the obvious answer? Both, right? I mean, yes, you wanted to give them a choice and you want them to choose, they will invariably choose both, right? Most adults would do that too. Right? That's, but we tend to sometimes get confused because in English, many times when we say or, we mean exclusive, right? And it's kind of, depending on context, which one do you mean? In math and logic and programming, it always means inclusive. Does that make sense? And we can combine these things, so we can do A greater than B and B less than 12. B was 11.1, so it is less than 12, but A is 10, so the first one is not. This one would get me true. This one would get me false because they're both false, right? I could do this, or I could do not. There is a precedence of operators. It usually makes sense. I tend to use parentheses for most of this stuff other than plus and minus, because I tend to get confused. I know it by mind, but I still feel confused. So I tend to put extra parentheses. I don't think I needed the parentheses here. The comparison operators would associate higher than, no. Okay, never mind. We needed the parentheses. Rather than trying to remember whether I need them or not, I normally put them. But does this idea make sense? it is one, I'm gonna warp your mind in this class. Hopefully after this class you will think differently. One of the things that should warp your mind is this, right? In English, we tend to not combine Boolean values. We tend to not see Booleans as values that you can apply operators to and things like that. In programming, that is what we do every day, right? So this should warp your mind. A lot of people are doing assignment 1, getting ahead, and you have done programming, but you haven't warped your mind. So you're using if statements. There is no if statements needed for assignment 1. We haven't seen if statements. So you will not need them. I will bug you if you use them. I'll still give you the points, but I'll bug you. Because I want you to warp your mind. I want you to just combine Boolean values. Make sense? Cool. Oh, just let me mention this. It should not matter, but Java does what is called short-circuiting. What you have on both sides of those operators can be a really complex expression, right? That may do other stuff, may have side effects. Java uses short-circuiting if you're using and the first operand is false, it doesn't go execute and evaluate the second one because it knows that the result is false. If you're doing OR and the first operand is true, it won't go and evaluate the second one because it knows that the second one, that it doesn't matter, the answer is going to be true. This doesn't matter right now. It probably won't matter throughout the class, but sometimes you can do those kinds of things. For example, right? You can do like a different than 0 and a divided or b divided by a greater than 1, right? Why do I need to do the first a different than 0? Because if it's not, right, if I make a equals 0, if I just do b divided by a greater than 1, it's going to complain. Well, yeah. In floats, you can actually divide by 0 and you get infinity. In ints, you don't, so you get some sort of exception. Whereas if I do this, this will work because I have this guard first and this gets done first. Does that idea make sense? It will not try to evaluate the second part. Sometimes it can be useful. It's mildly important for you to know that it exists. And that is called short-circuiting. We talked about the relational operators, equal equals. Oh, we didn't see bang equal, not equal, which is exclamation mark equal. There's some exercises you can go play. You can actually go play in Java REPL and figure out. How do you make this second nature? Go play with it. Type 100 of them, right? How many do you need to type? I don't know until it becomes second nature to you, right? Some of you may have done it already, and so just go practice with a few. Some of you may not have done it, and then you need to do 100, right? It is a lot better if you do the more you do, the better, right? It is a lot better if you do several per day, rather, right? If you do it over several days, rather than try to cram, usually, right? Java REPL is nice because it's on a browser. You can go wherever, no matter where you are, right? You can go play with it. It's not a full Java IDE or something like that, but there's nothing to install on your computer. So you can do it from your phone when you are waiting for the bus or something. Play all the time, right? You should be doing this stuff all the time. One more thing, strings are actually weird. In Java, we have a distinction between primitives and objects. Ints and floats and those things are primitives. They're basically just values. The value tree will always be equal to tree, right? It's equal to every other tree. They're all the same thing. Objects have an identity, and so they could be different even though they look the same. In Java, strings are weird in that they are objects, but they behave like primitives most of the time. So right now we're going to talk about them as almost primitives, and then we'll see objects and we'll see. Actually, we declare a variable in Java is an object, so it's capital S. We actually have char, which is one letter. And we denote character constant with single quotation marks. So I can do char c equals A. This is not the variable A, this is the letter A, right? By the way, I should have mentioned, Java is case sensitive. If I ask for the variable AA, it will tell me 0. If I ask for the variable AA, it will tell me blah. Right? Capitals are different than lowercase. And in terms of numbers, right, capitals are different than lowercase. Does this make sense? Single quotes for character constants. A string is a bunch of characters, right? And we use double quotes. So string SA equals, and we use the double quotation marks. Sometimes we need to use weird characters. In Java, as in C and every other language, we use a slash to escape those weird characters. So for example, /t is the tab character. When it prints it as a tab, right? So it's not. But I can do, for example, SA plus C plus SA, and you can see the tab there. It's that big space. Java doesn't support operator overloading, so there aren't too many weird operators, but it does support plus for concatenating strings and strings and letters. So we can use plus for adding strings one after the other. Now, strings are objects, and so once you have an object, we will see this next week probably, but let me give you, we can use the dot operator and then a method to ask the object to do stuff. So, for example, strings have length, so that will tell me how many does it have. Since SA is the string containing the letters O and E, its length is 3, right? Other things that I can ask for from a string is equals to see if it's equal to another string. I can ask it compare two which are similar. Concat is instead of plus. Substring gives you a piece of the string, and char add gives you. So I can do sa.char add 0, and that will give me the letter O, the uppercase O, which is the first letter, right? In programming, we start counting 0, 1, 2, 3, right? Your elementary school teacher lied to you. You don't count 1, 2, 3, you count 0, 1, 2, 3. Makes sense? I don't think you require strings for assignment 1, but we are using them all over, so I figured we'll cover them. We'll really talk about objects next week, I think. Maybe. Or the week after. Or the week before. One of those days. Yeah. We are more or less done with module 0, and we can go play with slightly more interesting stuff. It is cool to be able to combine operators and to do, right, 3%, 4, and those kinds of things, right? But we want to use our programming as more than a calculator, right? Functions allow us to start defining abstractions, defining our own language. What we do in programming is create a language such that talking about what we want to do becomes easy, right? So you need to build all of that stuff, and then it's just, oh, just do this to the computer, right? So the functions allow us to do that. They are similar to mathematical functions, right? You remember middle school, mathematical functions, boxes, stuff coming in, stuff going out, right? This is the adult version of that stuff, right? Naming is going to be even more important. And we normally want this to be close to mathematical functions, in the sense that you always produce an output, and you only produce an output, and you don't touch anything else. So what does the syntax look like? A function returns a value, produces a value. So first thing we say is, what kinds of values does it produce? It produces booleans. We call this is-even. That's the name of the function. We are going to pass it one parameter, which is going to be an integer. And inside the function, I'm going to refer to it as number. And then what I'm going to return from the function, what I'm going to yield to the outside, is the result of this expression, right? And that's the number modulo 2 is equal to 0. That's the definition of even numbers, right? If you divide by 2, you get no remainder, right? So we can try to do this in Java REPL. And if I recall correctly, the problem is that Java REPL hates enters. And so this is going to complain about me. Yeah. So let me, this is horrible, but that's when Java REPL stops being very useful. Because writing them in one line is horrible. And once you start doing stuff that should be in 10 lines, trying to write it in one line should give you a headache. But So once you have that function defined, right, you can call it and give it a value. So if I call it with the number 3, right, what's going to happen? It's going to come, substitute 3 instead of number, and so it's going to return number, which is 3, modulo 2, which is 1. Is it equal to 0? No, so it's going to return false. Is even of 6 would return true. Does that make sense? Let's do you did this in assignment 0. What does this function do? It adds 2 numbers, right? What kinds of values does it return? Integer. How many parameters does it take? 2, right? And inside the function, they're going to be called A and B, right? So I can call add 3, 5, and what should this return? 8. Make sense? And then I can combine these in expressions, right? Add 3, 5 plus add 1, 2. So I basically created my own thing, right? It's not terribly useful because I could have used plus, but and then I can do stuff like is even what would this return? And you need to start, right? Add 3, 5 would be 8. Add 1, 2 would be 3. So add 3, 5 plus add 1, 2 is 11. And is that even? No, right? So we'll get false. Make sense? You can combine this to as many levels as you need. Does that make sense? It is a very good idea to have your functions don't have side effects, right? Just they take values, operate on them, return a value. They don't touch the world. They don't change anything else. We'll see how to change stuff later. But make sense? Okay. I think we need to do this now. I'm gonna create a new project and I'll figure out how to post this, but just plain Java project. Create it from this command line app. Let me actually get ahead. And talk about a full Java program because now we can't use Java REPL. What does it look like? In Java, you define your things inside packages, which are like folders. So we're going to have tons of things and objects and stuff like that. You need to organize them. And so by default, this thing created com.company as the package name. And I'm not going to touch it. You have a class. And for now, assume that this is just boilerplate. Just memorize it, right? The name can be whatever. And then inside that class, you have a magic method called public static void main. and it has one argument, which is a string and square brackets. That's an array of strings. We'll talk about arrays halfway through the course. So just assume that this is magical incantations that you have to produce. And then whatever you do inside of this is where your program starts and whatever stuff will be executed. Now, there is one more thing, right? We have Java REPL where the REPL is printing the values, right? In here, there is no REPL, so your program needs to produce output, do something to the world, right? In Java, you do that with system.out.println. And then you can put any string here or almost anything. Java will convert almost anything to a string if you ask it nicely. So here we can write 3 plus 4. When we run this, we get horrible warning message and then the number 7. We run it, and now we're going to get a bunch of things. Make sense? I can define my own functions here. For now, take this as gospel. Write static before this stuff. We'll see what static really means, but now let's start making everything static. And you will see in the assignments all of the functions were static. We'll see what it really means somewhere later. So what would this print now? False. What happens if I just write here? What would this print now? Still just false. Because I didn't tell it to print the other guy, right? So it generates the other guy and then discards it, drops it on the floor. Because I didn't tell it to print it. If you want it to be printed, then you have to ask for it to be printed, right? Let's see. We can define a few more functions that do weird stuff. Do you have any questions? No. So this one would return true if any of its, if either n1 or n2 are even, right? How can we write that? Would be nice if we had a number that a method, a function that tells us whether a number is even, right? Oops, and then we are not doing anything. Make sense? How could we write this? Whether the sum of those two numbers is even. Yeah. Make sense? So what would this print? False and then, actually it should print true and then false, right? Is any even should print true and then false because the sum is 7 and it's not even. Yay! Make sense? Any questions? Not right now. Let's do functions that take other stuff and try to combine this thing, right? Boolean is big. So we define big numbers as those that are above 1 million. So what do we do? What do we return?
I think we return n. If we return less than 1.
Make sense? The sum of the lengths of two strings. You're given the strings. What do we do? How do we get the length of a string?
Swap dot length dot
Yep.
length plus
So we are always doing return, right? That's what you're getting back. S1 dot length plus S2 dot length. Make sense? Or which is not quite the same, but the end result is the same. Concatenate both strings and then take the length. But I like it better the other way. We didn't make it static. So we should get hopefully 7, right? Make sense? Cool. Any questions? Inside a function, we can define variables and they have local scope. They only live inside the function. So if doing this confuses you, you can do int L1 equals S1 dot length. Make sense? these two variables, L1 and L2, only live inside the function. When you call the function, they get created for that execution. Function returns, those variables disappear, right? Make some sense? And so we would do the exact same thing. Cool. Scope. Yeah, you can call other functions, which we have done. You can compose them. Next class we'll do more examples and play a lot more with functions. This should give you enough to do assignment 1, at least to try. And so, just a reminder, programming is very unforgiving in that it's binary. Your program either works or it doesn't, right? So 5 minutes before you're done, what's your grade? 0, right? And then you're done and you feel really good. It's not 0, right? It's 0 per thing, right? So you have 5 or 10. So, but before you're done, right? It's not linear. In English or something like that, if you need to write a 5-page paper and you write 4.5, you get an 80, right? Rather than 100. But here, if it doesn't work, you're getting a 0 on that particular assignment, right? So, how do you deal with that? Start really early, as in tonight, right? And then if you get stuck, you can ask, you can submit, right? You can ask. You guys have the advantage that you are face to face, so you can physically ask on Thursday. But either way, right, you can always submit pull requests and ask me and do those kinds of things. And with that, I will give you back 1 minute of your life. It is 7:44.